Welcome to Academic Guru's Tutoring Tuesday, where we answer all of your high school, college, and university questions. If you would like your question to be featured on next week's Tutoring Tuesday, please submit your questions to questions@academicgurusinc.com. Don't forget to subscribe so you can stay current with all of our new videos. In today's session, I'll be solving two arithmetic sequence questions that were posed by Claude. The first question asks, find the general term of an arithmetic sequence that is T6 equals 15, T11 equals negative 20. Hence, find the value of T17. The second question asks, find x if 3 minus x squared minus 2x and 1 minus x are consecutive terms of an arithmetic sequence. I will start by solving part 1 of the questions, and I think before attempting this question it's important to understand what arithmetic sequences are. By definition, an arithmetic sequence is a series of numbers for which any consecutive number can be predicted by adding a constant term d to the preceding term within the series. In other words, if you were to have some sequence 2, 4, 6, and 8, you can see that by adding 2 to each term within the series, the following consecutive term can be found. That is, the constant term d is equal to 2. So if we were to rewrite these numbers in terms of the terms T1, T2, and T3, then T1 being the first term is equal to 2, T2 being the second term is equal to 4, and T3 being the third term is equal to 6. And you can readily see that in order to find the second term 4, you simply need to add 2 to the preceding term T1. The same thing holds true for the third term, where by adding the constant term 2 to the second term, you will find the third term 6. In order to answer these questions, you have to start with the general arithmetic sequence equation. It simply says that the nth term, Tn, within a series can be found by adding the first term, T1, to the product of n minus 1 times d, where again d is the common difference for each successive term of the sequence, and n describes the position of a term within a sequence. In Claude's case, we are told that the 6th term within the series is equal to 15, and the 11th term within the series is equal to negative 20. Therefore, if we use the general arithmetic sequence equation, we find that T6, which is equal to 15, is equal to T1 plus 6 minus 1 times d, which is equal to T1 plus 5d, and therefore T1 is equal to 15 minus 5d. We can do the same thing for T11, which is equal to minus 20, which is equal to T1 plus 11 minus 1 times d, and this simply narrows down to T1 is equal to negative 20 minus 10d. Now we have two terms which we can equate to one another in order to solve for the constant term d. After equating the two T1 equations to one another, we find that 15 minus 5d equals negative 20 minus 10d, and after adding all the terms together, d equals negative 7. Now that we know what d is, we can solve for the first term, T1, by plugging d into either of the T6 or T11 equation. I will work with the T11 equation. So after substituting d with negative 7, we find that T11, which equals negative 20, is equal to T1 plus 10 times negative 7, and therefore T1 is equal to 50. Now that we've determined the values for T1 and d, we can solve for T17. Again, the general equation says that the 17th term is equal to t1 plus 17 minus 1 times d, which equals 50 plus 16 times negative 7, and therefore the 17th term is equal to negative 62. Now that we understand some of the principal concepts behind arithmetic sequences, we're ready to move on to question 2. Part 2 asks us to find x if 3 minus x squared, negative 2 times x, negative 2x, and 1 minus x are consecutive terms of an arithmetic sequence. Given what we've just learned about arithmetic sequence, it must be true then, in a generic arithmetic sequence, the difference between two sequential terms must be equal to some constant d. In other words, if we were to define the first term, t1, is equal to 3 minus x squared, and the second term, t2, which is equal to negative 3 times x, or negative 3x, then the third term, t3, is equal to 1 minus x. Since we've defined our constant term as d, it must be true then, in order to determine the second term, t2, t1 plus d should equal t2. The same holds true for finding t3. By adding d to the second term, t2, you can solve for t3. Therefore, if you take the first equation, we find that then 3 minus x squared plus d is equal to negative 2x. And the second equation tells us that negative 2x plus d equals 1 minus x. Now, given that we have two unknowns in these two equations, let's start by eliminating one of them by solving for d. d for the first equation is equal to x squared minus 2x minus 3. And in the case of the second equation, d is equal to 1 plus x. Now that we've defined d for both equations, we can solve for x. After equating the two equations to one another, we find that x squared minus 2x minus 3 is equal to 1 plus x. This narrows down to the quadratic equation x squared minus 3x minus 4, which is equal to 0. After using the factoring method, which we described in one of our previous sessions, you'll find that this equation can be factored into x minus 4 times x plus 1, which is equal to 0, and therefore x equals 4 and or negative 1. We hope you found this helpful, Claude. Thank you for tuning into our Tutoring Tuesday channel. If you enjoyed watching this video and found it helpful, please give us a thumbs up, comment, and subscribe. We would love to hear from you. Until next week's Tutoring Tuesday, happy studying.